All right, good morning, everyone. We had a bit of a technical glitch to get started. So Jeff told us a great story about his boat, who we're going to have to redo another day.
Yeah, let's do that another time. All right, let's dive right in.
So we're going to dive in. Here we are, Triangle Mountain Motors. Good morning from Victoria. Let's see, what's our question here? This is a good question that we actually did a video about recently. Jeff, my battery compartment has a fuel line running through it. For electronic purposes, would it make the engine? Is there a reason for spark-proof fuses here?
Yeah, that's a really good question. Especially, it depends what type of fuel, right? We have to talk about, there's certain fuels that are more likely to be combustible than others. So gasoline is the one that we worry about the most. And that's the one that doesn't take a lot to ignite, right? Diesel, you hear the stories, you can throw a match of diesel and it won't start. That's why my understanding is that's why some of us have those glow plugs, increase the temperature. So it's actually hard to cause diesel to catch on fire. But gasoline, we know, a lot easier. If your boat has gasoline sort of fuel lines, well, first of all, you got to make sure that none of your electrical wiring is following those fuel lines. And I've seen that on electrical audits. So that's the first thing, is making sure your fuel lines are completely running separate paths than your electrical circuits. Second, if you've got gasoline on board, make sure that wherever that gasoline, especially where the gasoline fittings are, so any type of fittings, right, between fuel filter and something else, it's rare that a hose will just simply, have an opening. But a fitting, right, a handoff between one thing and another, between a fuel filter or a fuel pump or whatever it is, that's what we worry about. So in those compartments, wherever you have fittings on your pipes that are feeding fuel to your engine, make sure that everything in those compartments are ignition protected. And so the fusing should be ignition protected. You don't want the fuse to blow and cause a spark, which causes an explosion. So that's a great question. Really, to be honest, too many of us discount a gasoline engine room and don't take it as seriously as we should. Nothing wrong with having a gasoline powered boat. A lot of us do. But when we do, we should take extra precaution to make sure that we don't have a kaboom on our boats. So great question.
All right, we have another question here from Mark. Can I use a lithium battery as a starter battery?
Well, Mark, we don't recommend using a lithium battery as a starting battery. I think it's definitely doable. There are reasons why we don't do it that way. We'll have lithium for house, and then we'll have an AGM battery for engine start. And then we'll probably put in a battery isolator between the alternator and both batteries, the AGM and the lithium. The alternator will chronically undercharge the starting battery, but we'll fix that either with a solar controller or a battery charger that is just connected to the AGM battery. So when doing lithium, there's definitely arguments for having a lithium battery bank for your house and then having a flooded or AGM lead acid battery for your engine start or even thrusters. So divide and conquer when you're doing lithium.
Yeah, sort of a second part question. He has a 5 kilowatt generator. Can it fully power a 3,000 watt, 120 amp inverter charger?
The answer is absolutely yes, no doubt. 5 kilowatts is tons of power, and a 3,000 watt inverter charger with a 120 amp charger is going to draw about, I'd say, probably 23, 25 amps at AC. And your generator, your 5 kilowatt generator, can probably output 40 amps continuous, no problem. So yeah, you can definitely run that large charger as part of the inverter charger from that generator. Give you an example, I had a boat owner that we just did a testimonial for. He had a 5 kilowatt generator and we were charging 350 amps at 12 volts DC from a 5 kilowatt generator. We had put on board 3 inverter chargers in parallel. Well, actually 2 chargers that are 100 amp each and 1 inverter charger that's 150 amp. So we were able to do that off 5 kilowatts. So 120 is no problem at all.
All right, question from Victor. Hey, Jeff, is an engine room a suitable place to mount an MPPT controller on a typical sailboat?
That's a good question, Victor. sailboat engine rooms are really quite an inhospitable place. If we could shrink ourselves down and actually be in that space when the engine is running, we would be bashing the door to get out. Why would we do that? It's because it's insanely hot in those spaces. There is no engine room on a sailboat, not the little sailboats that most of us have. Of course, I bet, a 100-footer would have an engine room, but most of us as sailboaters don't have a real engine room. And that engine room is too small and there's not enough air, especially not air itself for breathing, but exchange of air to cool down that space. An MPPT controller is a piece of electronics, like an external regulator for an alternator. I would avoid putting those in the really confined space of a sailboat engine room. And I would do that because just sometimes that space can get really smoking hot and it's hard on the electronics. So try, if you can, to find another place and do not put it in that tiny little engine room. Don't do it.
All right. We have some people joining us from France. Maybe a good morning.
Bonjour tout le monde.
Chris writes, I honestly wish I had found your channel before buying the used boat. Had a bunch of electrical modifications, and I'm absolutely not comfortable on it. So thank you. Here's a good question. Can
You're
you
welcome.
put an alternator regulator on an older alternator, or should I upgrade the alternator?
Oh, that's a great question. And it's funny, yesterday I had feedback from a YouTube subscriber telling me to maybe flush out a little bit more of the details on an external regulator with an alternator. So first of all, let's remember this. All of us in our cars, in our boats, all of us have regulators on our alternators. It's absolutely essential. An alternator without a regulator is incomplete. It won't work. So all of us have a regulators, and the job of the regulator is to basically control the voltage, right? So that we never overcharge a battery that is connected to the alternator. And generally that outputs about 14.4 on a 12-volt battery. Double that for 24, and some boats have 32-volt, starters, alternators, again, separate. But let's, for comparison, let's call it 12. So you've got every alternator has a regulator. You can definitely bring an alternator to an alternator shop and have them remove the internal regulator and give you what's called an external field. So they'll show you a post on the alternator and say, okay, you want to connect your external field to that. And that's where then you bring in an external regulator, and the external regulator drives the alternator via this field post. It's a little bit like, the way I think about it is the way that we drive our cars. Think about the actuator for the gas pedal. Right? We're moving the pedal maybe an inch, right? And by moving that pedal an inch, we go from 0 to full speed, right? And so the external regulator does the same thing on the alternator. By applying what's called a field voltage on that post, it drives the alternator from 0 output to max output. And the job of the external regulator is to do a better job of the internal regulator, because it's way more money and it can do a 3-stage charging. So in short, you can absolutely get an old alternator modified to be external field by removing the internal regulator and installing an external regulator on it. And we've got a whole section, by the way, on our website just on that topic. I've got conversations just on that. And don't forget, for some of you that are geeking out and want more, subscribe to our channel to hear more about those things. All right?
All right.
Good
Adam
question.
has a good question here. Adam says, I've learned a lot and couldn't have done most of it without you. So thank you, Jeff.
Thank you.
The owner before me put in a non-marine inverter in my sailboat. Are there pitfalls with this?
Oh, yes, absolutely. Non-marine inverters will actually, most of them will do what's called a ground to neutral tie always in the inverter, which, by the way, is catastrophic on a boat, because unlike the non-marine world, our boats, if you ever do a ground to AC neutral tie, you are one step away from death and electrocution. The other thing that you would need to be a complete perfect disaster would be reverse polarity. So if you have reverse polarity on your boat, which could happen when you plug in the marina, so that's where the ground and where the hot and the neutral are inverted. So now your hot's not hot, but the neutral is hot. And if you do a ground tie, AC neutral ground tie, then basically since your neutral is hot, and it shouldn't be because that's reverse polarity, and you did a ground tie between your neutral and your ground, now your engine block is 120 or 220. You're literally pumping into the water 120 or 220 volts. Your sink is energized, your chain plates are energized, your keel, whatever bonding system of your boat, all of it is energized. And this is actually how people die, especially in freshwater or marinas that are saltwater with a freshwater layer. So yes, a non-marine inverter needs to get out of your boat as soon as humanly possible. There is no justification to having an inverter that does an AC neutral to ground tie, and get that thing out of your boat. Yeah.
So that was a good question, Adam, all the way from Sweden.
Oh, thank you. Yeah.
And now we have a question, Brad from Seattle. What is your take on direct DC generators? Good and or bad?
Yeah, it's a great question. And they're becoming more and more popular, right? So the concept is, if you're going to create power, why go through the route of an AC generator, assuming you don't have one on board, right? So I'm assuming you have a choice, because a lot of us as power boaters are going to have already a generator on board. And we're not advocating here that you change your AC generator to DC. That's not the point. Given a choice, now you're designing a boat, you don't have a generator. Should you do an AC generator or a DC generator? It's a valid question. If you're not running a large AC loads on your boat, you don't have a garbage compactor, you don't have an AC water maker, you don't have a lot of these large AC loads, maybe no air conditioning. Why would you create a form of energy, alternating current, when you're really not using it and you're just going to retake that energy and convert it back to DC via chargers? Why not skip the middleman? Great question. And a lot of people, absolutely, especially boats that are inverter-based boats, right, where all the AC loads can run through an inverter, it does make sense to have a high output DC generator that's outputting 200, 250, 300 amps at 12 volts to recharge a battery bank that can take it. You need a battery bank that can take it, and have that power just go directly from generator to battery without having to go through a charger. So I don't think it's crazy at all to go with a DC generator. The challenge is most of us already have generators on our boats. The ones that are going to have one already do. So it's a question that applies only to very few of us that actually are contemplating generators and don't have one. But yes, absolutely worth considering.
All right. Franklin would like to know, what is the cheapest AIS transponder, or what do you recommend?
Yeah, so Franklin, good questions. I don't ever, as a philosophy, I don't know if I got that from my dad, but I figure that the least expensive is probably one of the worst values. Sort of the way I look at those questions, I tell people, Wendy's is probably the cheapest meal you can buy here in Canada, but it's by far not the best value, right? You can go spend a couple more dollars on your meal and not have to spend $4 for a meal, and you'll get way better value if you spend a few more dollars. So least expensive is not always the best. Within the world of AIS, so AIS stands for Automatic Identification Systems. It's a way for ship to ship or ship to shore to communicate with one another without actually having anybody in the middle, right? So it's actually made point to point. I would recommend, if you were budget conscious, so not the cheapest, but let's use the word budget conscious, and a lot of boaters are, absolutely everyone is, to be honest, even the billionaires are budget conscious. I would recommend as a starting point the Amtrak. In terms of what you get for what you pay, it's probably unbelievable value. Now, there are products out there like Vesper that are actually more money, but they are more features. I think both products have about the same value. You're just going to have a no-frills product is probably the Amtrak. And then if you want to have more sort of features and it makes sense, look at what Vesper gives you, and you can consider Vesper. Vesper is from New Zealand. Amtrak, I believe, is from the UK. Both great products, both different price points, but I would say comparable value, good value. Yeah.
So we have a question here, 39-foot sailboat, replacing the old battery with Fireflies. Is there a consideration with the alternator?
Yeah, well, good question. So whenever you're changing your batteries, period, whenever you're doing anything on your boat, absolutely, the way that this boater is thinking about is like, oh, what are the implications? What should I worry about? We should always do that. Assuming that something's just going to work is going to lead you down a path of a lot of disappointment. So when you're putting Fireflies on your boat or a new battery bank, there's different rules. So first of all, the question would be, do we have another charger on board or not? Like, are you going to be going offshore and just sailing, and the only means of recharging your battery is strictly running an alternator? That's a completely different scenario than a weekend warrior that has an alternator but also has a battery charger, and the battery charger is going to take care of the boat the whole week, and the alternator is just to maintain battery. So it really depends on what we're doing with the boat, hence why it's never easy. So let's run a scenario where most of us, let's for example, do have a battery charger. On this instance, 39-foot boat, we've got an alternator. So what I would do is, the good news is an alternator with an internal regulator outputs about 14.4. And luckily, the Firefly actually wants that as a charging voltage. Not the whole time, but that's what the absorption and bulk voltage will be. So good news, the stock alternators output what the Firefly want. Now, it's not going to be perfect. And if that was the only thing you had was just an alternator, then I would recommend installing an external regulator on that alternator, right? To make sure that that alternator is smarter and recharges the battery faster. And the other thing, if the alternator was the only device on your boat, then I would make sure that the alternator can charge the battery bank at a minimum of 20% of its capacity as a charge rate. So for instance, on that boat, if they had 4 Group 31 batteries, they're about 116 amp hours each, 110. So let's call it 440 amp hours at 12 volts. Your charge rate should be 20% of 440. So 20% of 440 is 88 amps. 88 amps should be the minimum charge rate. So your alternator should be probably about 120 at least with an external regulator, and then you can hit about 90 amp as a charge rate. So that's what you would do if you only had an alternator. Now, if you've got a charger and you're using your alternator only to go to a destination, but eventually you'll get back, then it's okay. You know, the alternator will do what it can and make sure that your charger is at least 20% of the battery capacity as a charge rate. So you should have a large charger or a large inverter charger, right, that can pump at least 90 amps. And generally, you're going to do that with a 2,000 watt inverter charger, right, that has 2,000 watt of inverter, 100 amp of charger, or you can even go bigger. But that's how you would make sure that your battery bank is charged at the right rate of charge. And you can do it with an alternator, or even better, an external regulator on a higher output alternator.
All right. Here we have a question from Linda in Seattle. She's doing a complete electrical refit, and she was basing it on Firefly batteries. But she's thinking now maybe lithium.
All right. So the pros and cons. You know, there is no such thing as a perfect solution for everyone. If there would be, we would have found it, right? We're all trying to crack this sort of puzzle, right? So the first news is there is no such thing on a boat as a perfect solution, regardless, even if you take away money. Even if you had $1 billion to spend on your boat, you had $1 million, you have 100,000, you have 10,000, all of us are making compromises. Every choice has pros and cons, and there is very, very, very rarely a perfect device. So generally the reasons for lithium, why people would consider lithium, is going to be space, right? Lithium comes in a smaller battery size for the same amount of energy density. So that would be one thing. You want a larger battery bank, but you don't have space for it. Lithium is perfect. Jeff, another thing, I'm worried about weight. I don't have that much weight. I need to have more energy, but I don't want to carry that much lead. I'd like to have higher energy density. Again, lithium is perfect. Another one, Jeff, I don't want my voltage to sag. I'm running loads that really have a hard time as the voltage sags that we would find through lead acid, because as lead acid batteries get lower and lower on the discharge, their voltage drops. But lithium doesn't do that. It's always steady and then it crashes. So that's another thing too. Some people say my loads are too sensitive and I want my voltage to always be steady. Another one too is lithium would be, Jeff, I'm going to be going offshore and I'm planning to go offshore for 5 to 10 years and I'm going to be using my boat every day, all the time. So how do you do that? Well, lithium is a really good contender. Why? Because you get the cycles. All right, that's pretty good. Another thing too with lithium is its ability to basically take whatever you throw at it. So if you have a large inverter, a large generator, and you can put multiple chargers, you could dump easily a crazy amount of amperage. Pretty much everything you can throw at it, the battery will charge. So they would actually reduce your generator runtime. Now, all those things are great, right? All of them, but they do come at a cost. And not all of us need those requirements. And that's what I always emphasize. We don't have to copy. It's not because someone wears a gold chain that you have to wear a gold chain, right? Maybe that person likes gold and you like platinum. it's important not to compare too much, because all of us have preferences and all of us have different requirements. And so if those things make sense to you, but do you really need that? Are you going to be going offshore? Are you going to make use of those 5,000 cycles? That's like 5,000 days on the water. Are you going to make use of that? Do you have the ability to recharge those batteries at 3 times capacity? Do you have no space on board and you need so much more batteries? Not all of us need those requirements. And so then it makes sense that some of us still choose lead acid, like for example, AGM or Firefly AGM lead acid, as a means to say, well, you know what? Yeah, they're great, but I don't need that. And I'll spend some of my disposable project money on something else. So we've got some articles about that. Again, subscribe if you haven't done so. Check out our website. I've got lots of articles and tech talks and everything else. We've got over 1,300 web pages just on information on all these different topics. So great question, and there's no simple answer. Yeah.
All right, this is sort of the same ilk. Jeff, you mentioned that the internal regulator on the inverter limits the output to prevent overcharged batteries. Would that limited output prevent lithium batteries from overheating the alternator?
Yeah, so now I'm not sure if I heard the question right. Are we talking about an alternator or an inverter charger?
Sounds like he said you mentioned that the internal regulator on the inverter limits, but it should be probably the alternator.
Yeah, so first of all, let's talk about those two concepts. And by the way, they're interchanged all the time. So alternators only function, and it's confusing because alternating current, right? Like it is confusing. An alternator only outputs power only when the engine is turning. That's it. Shore power could never exist. So an alternator outputs power when the engine is rotating. That's how that works. All right, an inverter charger, the charger function of the inverter charger only works whenever it receives alternating current from either a generator or shore power. So an inverter charger is basically going to act very much like an alternator when they're running, right? So the alternator runs when the engine runs. The inverter charger, i.e. the charger function of it, runs whenever it senses shore power or generator. Both of those devices, when they're now enabled from their different sort of power source, both of them are going to be outputting based on voltages, right? It's all voltage regulated, right? They're doing both of that. A lithium battery, for most of them, especially the budget ones, are not communicating back to the alternator or not communicating back with the inverter charger. They're simply at one point going to say, the BMS is going to say, enough. Basta. No puedo más. Spanish mean, I can't do it. Can't do it anymore. I'm shutting down. And what that's going to happen is they're going to actually disconnect the battery, period. And that's where it gets complicated. What happens when the BMS decides that it's being overcharged? And the budget lithium batteries don't communicate, they just protect, right? There's no communication port, there's no CAN bus, they're not talking to other things. They're just saying at one point, they just go, that's it, enough. And they pull off not only charging, but also loads. So that's the challenge with putting a lithium battery on our boats is, well, how do you have something that maybe at one point is going to say no more? Well, that's where it gets complicated. And AGM batteries come in. What are you doing with those loads? Can you run those loads off another battery if the lithium battery decides to protect itself? And that's the challenge with lithium. You know, a drop-in replacement is a dream. It's a fallacy. There's no such thing as easy on a boat. If somebody tells you something is easy on a boat, just give it time. You'll find out there is nothing easy on a boat. And lithium isn't easy. It has great advantages, but it also, like everything else, has its pitfalls. And it's not to say lithium's not great. It's just like everything else. Everything is nuance. There's good and there's bad. So that's basically both the alternator and the inverter charger will not protect the lithium battery from overcharging, even though it might be a lithium charge profile, absolutely. But at one point, if it's too much and the lithium is full and it's full, the battery will actually disconnect itself from the charging and the loads. And what's going to happen when that happens? That's what worries all of us, or should. Yeah.
All right, we're going to change directions because I think this is a really good question. Triangle Mountain Motors wants to stop putting multiple screws in his boat and wants to know some of your thoughts on wire management. Is there a product you recommend?
Yeah, that's a great question. Wire management, putting screws on boats is true. It's hard. Any hole in a boat, it's hard. Doesn't matter where it is. It's on a bulkhead, For, if it's a deck, it's even harder. There are companies out there that sell these sort of mounts that can actually be affixed, glued with epoxy to different surfaces. Obviously, the surface has to be prepped and everything. And there's boat builders that do that. They're actually gluing mounts that in turn you can actually zip tie cables to. So that's a good one. On my boat, I don't like screws to be put anywhere, but the flip side is I do it. I have mounts everywhere on my boat, like everywhere. Like I went nuts. I'm supporting the wires every 8 inches, 6 inches. It looks like a lunar shuttle. I love it. There's no chafe. Everything's in a bundle. It's neat. If it's not organized, I notice it right away. I'm a functioning OCD, as my staff and my team would remind me. Like I'm a little bit obsessive. So wire routing on your boat is important because remember, chaos is natural and order isn't. So the reason why you do that is you prevent chafe, right? It's orderly so that when you look at stuff, you can actually obviously notice something that's out of place. That's what you want. And you can either glue those well mounts, right? And the companies, I think it's actually, we buy them, it's WELD, weld. So Whiskey Echo Lima Delta. And they make a really good product offering of various things that you can glue to a hull. So that would be one way to avoid putting fasteners or screws in your boat. So great question.
All right, here's an interesting one. Jeff, can I use solar during the day to run the inverter and heat hot water?
Yeah, so in short, you can, but you're missing an element. On boats, we actually power our inverters from batteries, not from solar. So because we actually have batteries, so the solar would actually come into the battery bank, and that's how it is on my boat. And that's how it is on all the boats that we do, right? Large solar array, whatever it is, it doesn't matter. Solar array, recharge the battery bank, inverter running power from the battery bank. So solar's going in, inverter's pulling out, inverter creates power, right, from the battery and outputs to run AC loads. Now, running a hot water heater from a battery bank is technically doable, but let's put into context that a hot water, like a hot water tank or a water heater is going to draw like probably about 15 amps at 120. That's a massive load, right? And it's not going to do that for 2 minutes like a microwave. It's going to do that for like 30 minutes or 40 minutes. 40 minutes of running a 15 amp at 120 load is massive, massive. It's like giving a black Amex to me when I was a 12-year-old in New York City. Watch me spend. It would be crazy, right? And nobody can afford it. So how many boats have I had wired a water tank or water heater connected to an inverter, connected to a battery bank? I think I've done less than 5 in my whole lifetime because the battery banks have to be huge, huge battery banks to be able to sustain that load. So yes, technically absolutely feasible, but the logistics of putting a large solar array, a huge battery bank, huge inverter, to do that is going to cost a serious fortune. And that's why it never happens. Yeah. Or it does happen, but it's very rare.
All right, we have a question from Christian. I understand the minimum charge rate for batteries, but what do I do if an anchor for extended sailing and the batteries can only be charged at 10 amps or so? Does this damage the batteries over time?
And the answer is yes, it does. And you do what you can in life, right? You don't do what you want, you do what you can. So when we're boating and we're in an Anchorage and we don't have a high charging source, right? Because we're not connected to shore power, we're not running an engine. Well, how are you going to do that? How are you going to meet that minimum charge rate? Well, you're not. And that's okay. It's not to say it's the end of the world, but your battery life, of course, is not going to be the same if it's chronically undercharged, especially if you have an AGM battery or even a lead acid battery. But by the way, AGM and lead acid are the same. You have flooded lead acid, AGM lead acid, Firefly lead acid, gel lead acid. They're all lead acid batteries. It depends what the electrolyte, how it is. To be at an Anchorage for extended periods of time, for imagine a year, 2 years, 3 years, that's why cruisers would have to actually equalize their battery a lot more than people that get to connect back to shore power. So you do what you can. And that means your battery life won't be as good as you hoped, but that's okay. You're out cruising. You're in the middle of nowhere. Life is great. Yeah, so you might have to change your batteries more frequently than if you were connected to the dock. But hey, you're on the water living in paradise, so it's okay.
We have lots of people saying, don't forget to like and subscribe. So thank you.
Yeah, thank you. Thanks for the reminder, Missy.
Here's an interesting question. Jeff, I would like to replace my propane galley stove with an electric unit. What should I consider for this project?
Oh, that's a great question. By the way, this is a common challenge that new boat builders are facing. They're installing barbecues on the aft deck that are electric. They're installing electric stovetops. Like, for example, Boston Whaler is common. A lot of those Conquest have no propane down below, no propane barbecue. The whole boat is electric, and you can buy that boat with a generator, or you can choose to have that boat not buy a generator, which a lot of boaters here in British Columbia will do because we're not running air conditioning. So a generator is not necessary. And what they're going to do is they're actually going to put a large battery bank on board. And then they're going to have a good size inverter, so at least 3,000 watt. But it's not just the inverters that's important. We're talking about a significant battery bank. Like, we're talking at 12 volts. It's got to be at least 400, 600 amp hours, right? So that would be 4 or 6 batteries, like 4 golf cart batteries, AGM, or 6 of them, or 6 Fireflies, 4 Fireflies. That sort of battery bank on a 30-foot, 35-foot boat, running an inverter, and then the inverter would actually power the stovetop that's electric, and it would also maybe potentially power a barbecue at the back. But the biggest problem there is the battery bank. And the other challenge too, lastly, is it's one thing to do this once, but then what happens when the battery bank is discharged? How do you recharge that battery bank without a generator to run the inverter charger? Well, then you would potentially do that with solar or having high output alternators on the boat. So that when you are underway, you're making up for the time that you were using that power. So it's challenging to certainly run large AC loads on battery banks, not because you just need the battery bank to be big, but you also need to find a way to recharge it. So great question. And it's a common one. We face that all the time with new boat builders.
All right. We have a question from Phil. He says, I have dual shore power inputs that combine to a 50 amp shore power outlet. I'd like extra protection for my electrical system. Will I need 2 isolation transformers or just 1?
Well, yeah, so good question. If your shore power receptacle on your boat is 50 amp, right? It's 50 amp, so it depends. Do you have 2 shore powers that are 30 amps on the boat or a single 50 on the boat? If you have 2 30 amps on the boat, then you need 2 isolation transformers or 2 galvanic isolators. If you have a single 50, then you need only 1 isolation transformer and only 1 galvanic isolator. And when I say 1, I don't mean you need both. You need 1 of either. Galvanic isolators are more budget conscious, right? They're about $200-300 US, probably around there for a 30 amp galvanic isolator. But even better than that is an isolation transformer. Big boats, for example, some boats that are 60, 70 feet, 80 feet, to me that's big, those boats actually will have literally an isolation transformer on both 50 amps. They're going to be one at the bow, one at the stern, because generally the 50 amps are maybe 1 more forward and 1 more aft. And both of those AC outlets are going to have a 50 amp isolation transformer as well.
All right. Victor says, should all through hull fittings be bonded? None of our bronze fittings are bonded, despite coming from a reputable builder.
Yeah, bonding is almost like religion. It's incredible how opinionated people are on the topic. And there's a lot of contradiction. So now, mind you, you're asking me, so this is clearly my opinion, and I'm not trying to offend, because as soon as I'm going to say my opinion, I know some people are not going to like it. I researched this topic, and after my own conclusion of researching this topic and having done a few boats, is that yes, we do believe that you should be bonding all metal through hulls on a boat. I've done that on my own boat. Now, if you have Marlin through hulls, you don't need to do that. But if you have metal through hulls on your boat, we strongly suggest that you create a bond, that they should all be bonded, i.e. they should all be at the same potential, and that bonded system should be connected to your DC negative at one single point. Remember, one thing that they talk a lot about with boating is ground loops. So when you're doing any circuits on the grounding system on a boat, make sure there's only one path from any one point. Think about a leaf on a tree to a end point on a root of a tree. There's only one path between that leaf and that single point and on a root. There is no multiple paths. The sap only has one path from that leaf all the way to that end point of that root. So when you're thinking about anything related to DC negatives grounding, there can ever be only one path. And yeah, absolutely, I would bond the through hulls on a boat. And actually, most builders do. And we're talking about an incredible expense to bond. These boats that are 40, 50 power boats, the expense to bond all of those underwater fittings is incredibly enormous. And if the big boat builders are doing it, and these are not small line items, this didn't cost them $500 or $1,000. This must have cost them $10,000 in the build or even more to actually do that. If they went through that expense, trust me, it's worth it. So I would, Jeff Cote here, would recommend bonding through hulls on a boat. Absolutely.
All right, I have a question here. Maybe you can clarify a little bit. Jeff, I'd like to ask, can I charge a battery bank by solar panel through battery posts that feed energy to my panel?
Yeah, so let's back up. So actually, it's a good question. By the way, there's no such thing. It's great. I'm glad, because some of us are thinking, oh, well, that's obvious. Well, actually, you know what? I've answered enough questions long enough to know nothing is obvious. And I remember when I started, all my questions were unanswered, and all of them didn't make sense, because what I'm trying to do is I'm trying to understand the concepts, right? Once you understand the concepts, then magic happens. So you've got a solar array, right, at the top. That solar array is going to be connected to the batteries, but there needs to be something in between. You need a brain. You need something that decides when it's time to charge that battery and when it's time not to charge that battery. Because remember, that battery might be full, and it might be sunny, and it's in the summer, and it's sunny every day, and it's blue skies, and that battery is no loads on it, and eventually it will be full. How do you prevent a battery that's full from being overcharged when it's sunny? Well, you have to have a device in between, and that is a controller. And you can either have a PWM controller or an MPPT controller. We're big fans of MPPT just because they're more efficient, and I can also do a better charging curve. And some of them, like Victron, you can actually customize, which I love, and I can give the batteries exactly what they need. So the question is, yes, you can connect your solar to your batteries, to a battery post, but in between the two, you have to have a solar controller. And that's what is going to make sure that your batteries don't ever get overcharged, but at the same time get charged with solar.
Hey, we have just a comment here from Drew. Hi, Drew. Jeff says, thanks for confirmation rebonding. Just had a system installed several years ago, and I really wasn't sure it was all necessary.
Totally necessary. I would have done it, and it's hard. I did on my boat. It wasn't easy.
All right. Let's see. Hello from Lisbon. Hey, Eric.
Oh, wow.
Thank you for this great information. Is it possible to install an inverter for 220 volt and 110 volt AC output?
Yeah, it is. The question is, can you have a single inverter that does both 220 loads and 120? Yes. Now, you're not in the land of these anymore. We just did a Bavaria R40 where we've done that. So it is absolutely possible. You're going to need what's called an auto transformer on the output. So Victron has a product suite that does that. You can actually have 220 in with basically running both 120 loads and 220 loads on the output. It is possible, but it's not something that's plug and play. So definitely doable, not super easy, but some boats require it, because some boats actually have both 220 and 120 loads, and you want the inverter to do both. So not crazy. So yeah, definitely doable.
All right, Ray asks, rather than installing external regulators on our alternators to deal with lithium, can we install DC to DC chargers from our start battery and eliminate the battery isolator?
Yeah, you can. So what you're suggesting there is having the alternator be directly connected and only connected to the starter battery, which most of us have. And then literally having the house battery, which is lithium, only charge via DC to DC charging converters. The challenge is, and it's not that it can't be done, is that they generally top out at about 30 amps. So if you've got a battery bank and you've got a 200 amp alternator on that engine, well, that's a lot of DC to DC charging converters that are going to have to be connected between your engine battery and your lithium house battery. So definitely doable. The challenge is that the lithium needs the most amount of power, and you're charging an engine battery, and then you're taking that and you're converting it to lithium. So it's the throughput. So that's why a battery isolator, you're not saving money by doing it that way. It's just a different way of doing it. A battery isolator, you don't have to have an external regulator to have a battery isolator either, right? You can actually have an alternator output to a battery isolator that would output both to the lithium and the AGM starter battery. And you can do that, and that would prevent the alternator ever being disconnected from the battery, which would never happen because you have a battery isolator that's connected to the AGM battery. So it's tricky, and I'm not sure that's the easiest way. And we rarely see that set up unless you have a small lithium battery and it doesn't really need a big charge.
All right, Jeff, I have a question from Rick's Repairs. He says, do I need an inline fuse near the battery if my inverter has fuses built in?
Oh, absolutely. Yeah, no shortcuts in life. I love it that you're asking, by the way. No harm in asking. No, because you got to protect the line, right? So remember, think about in our homes and commercial, right? The reason why we have these breaker boxes, they're not in one place because it happens to be convenient. It's not the reason. The reason is that it's actually the start of the circuit. So you need to have every single connection connected to a battery. And the only exception ADBY sees in a starter motor, and on mine is even fused, but that's the only exception in the code, is that only a starter motor doesn't have to be fused. Other than that, everything has to be fused. An inverter charger is going to be probably connected, that's 2,000 watt, maybe 2 watt, which is pretty big. 4 watt is the size of my thumb, right? I mean, it's significant. It's probably a centimeter in diameter with the cable insulation. So you absolutely need to have a fuse at the start of the circuit from the batteries to the inverter, regardless of if the inverter has a fuse or not, because the wire also needs to be protected. So great question. Thanks for asking.
All right, Werner wants to know, excuse me, Jeff, would your company design the electrical system or put together a professional drawing for a 52-foot blue water boat built in Slovenia? Do you do remote?
Yeah, we do. So we're doing probably about 500 design engagements a year, which sounds crazy. So we do this all the time. So boat builders or yourself as a boater, a lot of you want to have someone in your court. To me, it was like, I'm imagining how hard it was for me when I was doing this on my own. And I was like, where am I going to have my questions answered? And I was doing what you're doing, going on forums, reading stuff, reading everything, YouTube, all of it. And I was trying to get, well, let me try to get those answers. But sometimes some of us want to have somebody in our corner. We might have come up with an idea pretty far, but we want to go, okay, how about you help me figure it out? Be my sounding board. Does it make sense? Pros and cons. And absolutely, we have actually a whole section on our website just on that. You can reach us, and we actually do everything fixed price packages. So everything is known up front. It starts with a consultation, and then after that, you know exactly what different packages you can have depending on the information you're looking for. So actually, that's a big part of our business, is actually doing design for both builders and for do-it-yourselfers. Absolutely, yeah.
So we're having lots of questions about electric motors and electric engines. I'm trying to get through all of them and have sort of one summary question, but here's one. Hello, Jeff. Is there a way to monitor a 36-volt trolling motor battery bank?
Yeah, actually, Victron's battery monitors have a high input range voltage. So you could actually have a Victron BMV, battery monitor voltage, BMV, Bravo Mike Victor, and their input voltage is huge. So you absolutely can monitor a 48 volt, 36 volt, put a BMV and put the 7112, 712 and that's Bluetooth. So you don't even need, and now Victron even has even better. They have a smart shunt. You don't even have a monitor. Everything is just a little box, little black box, and then it outputs to a phone. So the Victron smart shunt will do that too. So yeah, absolutely.
One of my favorite topics, of course, is solar. So here's a good question from Jonathan. How would I rig a couple of solar panels mounted on the big boat to switch between charging a house bank and a small bank on my dinghy?
Oh, yeah, that's starting to get creative. Well, you could put a source selector, right? So you could put a switch that actually goes from, output, instead of actually having, normally source selector switches are battery 1, battery 2 to an output, but you could actually use the output, the common post go to battery 1 or battery 2. So you actually bring the solar to your common and then go to 1 or 2. The only thing that's really essential is that you cannot disconnect solar panels whenever they're outputting, right? Like you should not stop a vacuum from running, from yanking the cord out of the wall, because you can actually have sparking. So you would need to make sure that you change sources and that you always have a make before break, meaning that as you go from battery 1 to battery 2, that both batteries are always connected even as you connect. So it would actually go from 1 to both to 2. So it's always important to have a make before break battery switch to do that. Doable, rare. I've never seen it, but yes, something that I've thought about, and it's doable.
All right, Hayden says, on a smaller boat with an outboard engine and no metal below the waterline, what is the best way to ground the battery?
Yeah, that's a tough question because, if you don't have no underwater metals, some people are actually going to have grounding plates. Otherwise, you're what's calling your floating DC system, right? So your DC between your positive and your negative post is a voltage differential, right? Clearly, you put a multimeter. One is, the difference between the two on a 12-volt battery is going to be about 12 volts. But that doesn't make the DC negative ground. What makes ground is actually a connection to ground, which is what you're looking for. Some of them are going to actually have grounding plates just so that they can have a common reference point. So effectively, they're putting a piece of metal in the water, and they're using that piece of metal to connect the boat so that their DC negative is actually grounded. And that's how you would do it. Pretty rare. Most of the boats that I deal with don't have this sort of scenario, but I hear about it on the internet quite a lot, and I think that's how you would do it. By the way, if you have a boat with that, I'd like to hear how you do it because it's actually not that common, and I'd like to get more input on how it's done out in the field. So thanks, great question.
Just a follow-up question on your schematics. What software do you use?
So we use Microsoft Visio, old school. I used to work in network and telecom, and that's what we used in the telecom world, doing WAN networks in the internet. So we were using Microsoft Visio, so that's what's familiar. But I bet there's probably really cool tools out there that are much easier to use, but we use Microsoft Visio is what we do. We have a license, and we have a bunch of our technicians that have that license. Again, other people that have tools on drawing or doing conceptual schematics, please post what you're using. I'd be curious to see because I'm always looking to maybe do things better. Great question.
All right, Jeff, hello from Sweden. Installing a new diesel in my Miner 29 with 12-volt system.
Mm-hmm.
The motor has a 150 amp generator. Do I really need that big?
Yeah, so we would call that an alternator, but get the point. 150 amp, it depends. Now, first of all, remember an alternator, when it's rated, all of that is what I call sort of like, it's hopeful, okay? So an alternator, the first thing you got to realize is that's actually the cold rated output. So as soon as it becomes hot, you derate by 15%. So you take your 150, derated by 15%, right? That's significant. That's about 22 amps. So now you've got 150 down to 130. Now your internal regulator. An internal regulator is overly cautious, right? Because it's not that smart. So then you derate probably by another 2/3. So now your 120 or 130 is now 2/3 of that. So now you're at 80. Okay, now you remember you were 150, now you're 80. Now your output of your engine is a function of its rotation. So at low RPM, you're not outputting 80, you're outputting maybe only 20 or 30. And you're not gonna most likely gonna be wide open throttle at, let's say 31 or 3200 RPM on a diesel engine when you're motoring. So you take all of those, and you start from 150, and then you end up being probably about 75 amps, maybe depending also on the voltage drop, right? That's what you're going to get as an output. And 75 amps would be for a flooded lead acid battery. You don't ever want to charge them more than 20%. So, you know, you can have a reasonable sized battery bank with that. Probably about a 400 amp hour battery bank would be well charged with an 80 amp effective alternator output. So it sounds like an overkill, but it actually isn't, because of all the derating that happened from a theoretical alternator output to a reality alternator output.
All right, we have a question from Doug. Do I need a 2-bank charger for a 2-battery house bank?
Oh, that's a great question, Doug. No, the answer is no, you don't need that. So when we talk about, and I use this term constantly, battery or battery bank, remember, even a 12-volt battery is actually made of 6 different batteries, right? A lead acid battery is actually a 2.1 volt cell. So that's why you see a 12-volt battery has 6 battery caps. So that's 6 batteries in series to make a 12-volt battery. And that's why a golf cart battery is 6 volts, is only 3 of those battery cells. So those battery, when we buy a 6-volt, 12-volt battery, we're actually buying a series of batteries wired in series together to make 6 or 12 volts. So, all right. So if you've got 6 or 12, so that's one thing. What about putting battery banks in parallel? What about going 2 12-volt batteries or having 5 12-volt? I did a boat, we had 28 12-volt batteries in parallel. That would be called a bank. And when it's a bank, you only need 1 charger lead. Only 1 charger lead to do that bank. You don't need to have a charger lead on each battery of a bank. You only need 1 lead going to a bank. So on my boat, for example, I have 6 Firefly batteries wired in parallel because I've got a 12-volt boat. So those 6 batteries are wired as a bank, and that bank gets 1 charger lead, and 1 charger lead only. Great question.
And they're looking for your recommendations again this week, like they did a couple weeks ago. What's your opinion on the waterproof connectors used in the automotive industry?
Waterproof connectors in the automotive industry. I don't even know what those are because I live in the marine world. We use definitely connections. I wouldn't call them waterproof. They're never meant to go beneath the water, but they're heat shrink terminals. So what that means is that once you remove a portion of the insulation of the wire, and we have videos, by the way, just on this topic, 30-minute videos on how to do an electrical connection. We remove the insulation, we crimp a connector, and then we apply heat to basically have that connection be sealed. It's not waterproof, but it's to remove any potential of corrosion on the wire itself over time. Because as we know, a marine environment is a pretty harsh environment, and corrosion at connectors cause voltage drop and sources of heat. So I'm not sure about waterproof connectors. We use heat shrink terminals on all of our jobs because I believe that time is the most valuable thing in life, even more than money. And I figure if I'm going to do something on your boat or my boat, I want to do it once, and I don't want to have to do it again, not in my lifetime. So that's why we use heat shrink terminals on all our connections on boats.
Another one here is liquid tape. Have you heard of liquid tape, like AMP Super Seal?
Yeah,
connections?
I've heard of that. I've never used that. Again, we buy heat shrink, dual wall heat shrink for the lugs. So any cable above basically around 8, and I know I speak in American in that way because it's just, America's just south of us, and I mean, they influence everything. So from a number 8 gauge wire to a 4/0 wire, we use basically lugs, right? So they're metal, and we'll crimp them on the wire, and then we'll apply a 2 inches, so maybe about 4 centimeters, 5 centimeters of heat shrink that's going to be shrunk down to make sure that that lug is completely sealed onto the wire or the insulation on the jacket of the wire. And that's how we do it. So I've never used liquid tape. And I don't like liquid stuff because it's messy. And I like, again, OCD. I like my whole workspace to be as clean as humanly possible because it's just the way that I am.
Here's just a comment. Hi, Jeff. Thanks for sharing all of your knowledge. I've learned so much from your videos.
That's awesome.
Coming from Cape Horn in Chile.
Really? Oh,
Yeah.
God, I would love to go to Chile one day. Buenos dias.
Question. DC generator to feed 48-volt lithium battery bank.
Yeah, I don't know if they actually make a DC generator that's 48 volts. Maybe. There's nothing wrong with that. Again, nothing wrong. The only question is that DC generator cannot be disconnected when it's outputting, remember, right? It can't. So there needs to be a way to actually tell the generator stop charging the lithium battery bank. You cannot, absolutely not disconnect a DC generator suddenly from the only load that is there, which is the lithium battery bank suddenly. You can't disconnect the battery from the generator. You have to tell the generator to stop outputting. So what I would do is get a more sophisticated lithium battery with a BMS that can communicate and do relays and say, hey, by the way, I'm getting charged. I want to disconnect something. A little bit more sophisticated in the signaling and in the integration, as opposed to a lithium battery that just says, when I have enough, I'm just going to shut down and you figure out what happens. So probably doable. I've never seen a generator that's 48 volts. And again, if anybody has, please, we're all learning here, right? I'm learning too. So if any one of you know a 48 volt generator, DC, please chime in.
All right, we're coming to the close. We've got about 4 or 5 minutes left. I know there were a lot of questions today, some good questions that we didn't get to. So please visit our website at pysystems.ca. We have lots of contact forms there to ask your questions. And they're good questions, so we'll share them again on our next live stream. Let's see, what do we have here? Jeff, is there a fire hazard concern with LiPo batteries?
Yeah, so that's a lithium battery for the rest of us. Lithium ferrous iron, I don't know what it is. I can spell it out at the LiFePO4. Yes, there is. And that's the job of the BMS. The BMS is there to protect the battery management system on a lithium battery. And yeah, absolutely, there's been fire hazards. And that's the thing that causes a lot of fear in a lot of us, because on a boat, you just can't walk away from your boat. And if there's an electrical fire in a battery, it would be pretty end of the world sort of situation. So that's why a lot of us that are technical have hesitations with lithium, because we worry about things. That's our job to worry, right? And so make sure you choose a battery manufacturer that has a reputable history of making good BMSs that make the battery safe, and that they've got a hell of a track record at not causing fires. So absolutely, very important, and that's the job of the BMS, to prevent those fires from when the batteries are overcharging. Yeah.
All right, this has been a very popular topic, so I'm going to ask.
All right, let's do it.
Jeff, can you explain the purpose of a DC circuit grounded to seawater through the engine block?
Yeah, wow. Okay. So we do this in our homes. When we get when we get lines coming in from a substation, there might be 3 lines coming in, a hot, a neutral, and a ground, let's say. There's actually going to be a stake at every one of our residences, every one of our commercial buildings. Every single place is going to put a stake in the ground, and they're going to do basically a ground tie. The ground's coming from the substation, but we're also grounding, because what we want to have is everything be at the same potential. So in life, sometimes when you're and we are on boats going from DC to AC, everything has to be a common reference point, right? And the common reference point is ground. So when we talk about a 12-volt battery, a battery in itself is not grounded. It's not at zero. It's a voltage differential. Same thing with shore power. It's a voltage differential. It's a difference between 120 and 0, 220 and 0, right? But what is 0? If it's just a battery, it's not grounded. And so you want everything to be grounded to have the same common reference point, right? So that when you talk from DC to AC, you're not actually having voltage differentials between what should be common. And that's why it's called common grounds. And it's really useful for bonding. It's really useful for safety, right? Because you want the shortest path on an AC system to go back to the water. And for DC, you don't want to have floating ground. You want everything to be at zero. And the way to do that is to do it, for most of us, is via the engine block. And that's how that's done. By the way, I could do a 2-hour video on grounds. It's insane. I'm working on it. And for some of you, you're going to totally be geeking out with me. And for others, you'll be like, no, that's it, Jeff. I'm tapped out. I can't. I'm going. I got something else to do. But yeah, good question.
Here's just a recommendation for a topic in the future. How about a discussion on Espar heat? Do you, what does it say here? I hear you're dealers for that now. Is that correct?
Yeah, so we acquired a company called Roton Industries that's been in the business for 45 years. It was a big deal for me to bring this company on board with Pacific Yacht System. And yes, we sell a crazy amount of heaters, Espar heaters out of Germany, both forced air and hydronic. And that's actually a big part of our business, is actually both selling these heaters to other businesses that get them installed. Because here in the Pacific Northwest, it's never too hot or rarely too hot. And often it's just a little cold enough that you wouldn't mind having a little bit of heat. And a high hydronic heating system is a good way to create heat from a diesel source. You can do it also from kerosene, but diesel, and then you can keep the cabin warm. So for example, that's why I can boat in the wintertime, even when it's only maybe 5 degrees outside or 0, I'll have a diesel heater keeping via hydronic, keeping the whole boat warm, even though outside is relatively very cold and we're still not connected to shore power. Or don't have a generator running. So yeah, not crazy. Maybe we'll do something about that next time. Good suggestion.
All right, we're going to take one more question. I'm purchasing a yacht originally built in Europe, so it uses 230 and 50. I'm converting to 240 and 60. Will the current refrigerator and freezer need to be replaced?
Most likely, yes. The voltage is not the issue, right? Because your boat was 220 before, now it's going to be 240. The voltage is fine. The challenge is most appliances, most AC appliances are very specific in their frequency requirements. So they are literally going to say, I need 50 220, I need 60 220. And very few of them can actually work at both 50 and 60. An exception to that would be a battery charger. Battery chargers are actually good to take a huge input voltage range, like from 80 volts to 250, and from 50 hertz to 60 hertz. So a battery charger could actually run off of both. Most of them do, 60 and 50 hertz, but most AC appliances, including a hot water tank, right? We've got boats coming from Europe all the time. We're changing the heating elements within the hot water heater. We're changing the microwave. We're changing all these AC appliances so that they can actually run. Your inverter most likely won't. So if you have an inverter, it's either built for 50 or 60. That's going to be changed if there was one on board. So yeah, you have got to look at every single AC appliance, and please don't hope. You got to go through it. You got to make sure that it's actually able to run at 60 hertz, because some appliances are specifically made to only run off 50 hertz. Even though they're both the same voltage, there is a difference between 50 and 60 hertz. Absolutely. Good question.
All right, I said that was the end, but we're going to do one bonus question.
All right, bonus round.
Good question that we haven't had before.
All right.
When bundling wires neatly together, are there any issues with a 12-volt wire next to a 120-volt wire?
Yeah, there is. In an ideal world, believe it or not, the code says that AC wiring should not run parallel to DC wiring. Okay, now, that's easier said than done in most of our boats. And in an ideal way, you would actually want to run them actually perpendicular to each other. So on my boat, I actually went through the hassle of doing that. I actually have AC wiring running separate, and I have DC wiring running separate. Now, I'm a super geek, right? I'm chasing perfection all the time. So yes, given a choice, run your AC wiring completely separate from your DC wiring. And if they have to intersect, run them perpendicular. Or even better, you see this on ships, you see these wiring trays and you heave these wires going mixing, right? So yes, you should in an ideal world have your DC and your AC separated. But think about it, in a lot of boats, those come together in some places. You just try to, as much as possible, to avoid them being in the same bundle. Yeah, so great question, actually. It's hard to do, though. Easy to ask for, but really hard to do. All right.
All right. Thank you, everyone, for joining us. This has been a lot of fun. Any last words, Jeff, before we sign off?
I want to thank everyone for joining me. Honestly, this is one of the most energizing things I can do in a week. I love it. This is awesome. Thanks, everyone, for being here. It's super cool. Further questions, you know where you can find us. Make sure if you're asking questions and you're wondering, keep them concise. The longer the question, the more it becomes a consultation. So short and precise questions I can hammer out. If it's going to take me 20 minutes to read your question, 20 minutes for an answer, the likelihood of being able to answer, considering I work 100 hours a week, is very low. I'm just going to be honest. Keep your questions short, and then if it's short to the point, I'll answer them as fast as I can. And don't forget to subscribe. Also, for some of you that want to help us keep this channel ad-free, please maybe go on our merch store and buy some of our hats or mugs. We've got a bunch of stuff, because remember, we're actually not charging anything for this service. And then also some of you are donating on PayPal, and that helps us buy more gear. We're doing more stuff, getting more cameras, getting better. So thanks everyone for watching, and safe boating.
All right. Have a great afternoon, evening, wherever you are in the world. Thanks for watching.
Ciao.
Bye.
Bye.